Imagine if in the future we could predict and prevent all traffic jams. Hi there, my name is Gerrit Heikoop and I'm here at the Future of Information and Communication Conference in Singapore talking to the authors of some of the most highly reviewed papers. And in this episode I'm talking to Christian Backfrieder from the University of Applied Sciences in Upper Austria about his paper that was titled Robustness of Intelligent Vehicular Rerouting Towards Non-Ideal Communication Delay. Wow. All right, let's zoom in on this. Why do we need to consider these communication delays when we're talking about traffic management?
Yeah, thank you, Gerrit, for this kind introduction. Basically, there is a huge field of research done in this field, and you can optimize the traffic by just somehow intelligently calculate routes for drivers who are subject to traffic jams or will be subject to traffic jams in the future. And of course, this calculation and also the information exchange between vehicles and the system needs somehow to take place, and therefore the communication comes into the game. And of course also the communication is subject to delays, to errors, or even to information loss.
Yeah.
And this real communication then influences also the power or the performance of the algorithms, and this is exactly what this paper deals with.
Now, I wondered when I read that, I know about how Google Maps predicts traffic times, right? And they have an imperfect data set because they just say we have a few cars on the road that we know. How come this is a problem that we need to address? Because you could imagine just a few missed messages that wouldn't really affect the traffic flow.
Basically, I think Google predicts the traffic based on historical data. So, and I don't know if it's correct if you say predict when you talk about Google, since you basically always see the current situation on the road.
And not what it will be like once you get there.
Yeah, this is exactly what would be important, since if there is a traffic jam right now at a location that you will reach just in half an hour, you will ask yourself, is this still an issue if I am there? And this is why the prediction is that important.
And then it becomes more important to gather all the data because I need to know which other cars are intending to go to that same location.
Yes, absolutely correct.
Clear.
And you need to know first which cars will reach this this congested spot, and also if it makes sense to reroute some of them in order to relieve the situation.
Yeah, so these are very complex computations, very complex processes with multiple feedback loops. So tell us a little bit about what you did in your research. What did you look at?
Basically, the algorithm tries to predict, as I said, the congestion spots. And it does this by using the reports that vehicles are providing for the system, and they basically tell where I am, where I am going to, and where I intend to go to, and the system then decides or detects future congestions, and then allows a timely calculation of new routes, so that spacious reroutes become possible, which is basically the main benefit due to the prediction.
Yeah. Now, but what did you do to increase the robustness? How did you involve that?
Basically, this paper deals with investigations regarding the lossy communication and how the system is influenced. And what we found out is that the system we investigated is very robust against these delays, and this is for many reasons. And what we investigated is there are two types of messages we investigated, and these are first the ones that contain the routing information, the new routing information, and also the second type is the reports, the continuous reports of the vehicles to the system. And we found out that both types of messages or the system tolerates a very high loss rate or very high delays for both types of messages, and this is due to the reason that the way the system quantifies the way the system gains its information about the current situation on the road. Since it's not necessary that each vehicle reports the current situation, it is enough if just a few of the total amount of vehicles report their current position, their speed, in order for the system to get a correct view of the system.
Exactly.
And then
and you've tested that this extrapolation of data, that's still valid.
yes, it's still kind of valid, of course, if the percentage of correct messages is decreasing down to about 20% or less than that. Of course, then the system has a wrong picture of the whole
but
system.
Down to 20%, that's a very small percentage, right?
Yes,
so this is
compared.
very robust. All right. Now, for those viewers who've never been at a Future of Information and Communication conference, how would you describe your experience here in Singapore?
Actually, I was surprised of the big field of applications of future of information and communication, and I was really I heard really interesting presentations regarding also the communication. Yesterday I heard a presentation of a group that detects humor in human speech, which is quite a different field of research than I did, but still it's very interesting also to listen to other fields of research.
Interesting. Well, thank you very much, Christian. Thank you very much for sharing. And thank you very much for watching this video all the way to the end. If you're curious to learn more of all the other topics that are being discussed here at FICC, check out the other videos at the SAI conference website or on our YouTube channel, and hit the subscribe button so you'll be the first to know when a new video comes out. We're looking forward to see you at one of our future conferences.